Hello everyone, I'm Massimo and I'm a member of Team MLG, together with Luca Bertelli and Gabriele Bonanno. We are working on GABER, our spoken keyword detection system implementing a neural network on FPGA. If you want to better understand what our project is about, I encourage you to check out our introduction video. Today, I will talk about why we choose to use an FPGA for our project. There are four possible ways to implement a keyword detector. The most common one is on a general-purpose processor, but it could also be implemented using a GPU, an ASIC, and last but not least, an FPGA. Each one of these has its pros and cons, but let's see why we think an FPGA is the most suitable choice. First of all, our architecture has to be parallel in order not to create a bottleneck to the stream of input data corresponding to the spoken words being heard by the detector. The GPU, the ASIC, and the FPGA largely satisfy this requirement, while the CPU does not, as its architecture is inherently sequential. Second, we want our device to be specific for the task it has to achieve, in order to perform it at its best. For this reason, it's important to eliminate all the hardware parts that are not strictly necessary. Thus, with this requirement, we have ruled out the GPU because of its multitasking capabilities that, in our case, add no advantage. Then we want our device to have a low power consumption because we need it to be energy efficient in order to be suitable also for mobile devices. By this metric, it seems that an ASIC would be a better choice than an FPGA because an ASIC could be precisely engineered to be as low power as possible, lower than an FPGA, while at the same time maintaining the requirements described earlier. Why would we choose to use an FPGA then? The reason is because the FPGA has the unique property of being reconfigurable. We want our system to be dynamic and to be able to adapt to varying conditions. This cannot be done with an ASIC because after it has been produced, it is not possible to modify its architecture nor to program it to achieve another task. The only way this could be done would be to start back from the drawing board and redesign the circuit, but this would be both time-consuming and real expensive. An FPGA, instead, allows us to dynamically reconfigure the neural network, and this is really useful in order to improve its runtime. Indeed, we could be able to set more appropriate synaptic weights as the number of samples used to train the neural net increases. And the activation function of some neurons could also be modified to better detect the keyword. More importantly, the architecture as a whole can be reconfigured by adding new layers and adding neurons to each layer. This means that we could eventually be able to train the network to recognize new words or even new patterns, and thus making our system a machine that is able to learn. This capability is the key to create a device that keeps getting better and better, while maintaining the other useful properties. And this is why we believe an FPGA is the best choice to develop our project. Thanks for watching and see you next time.